Alright, so today we're going to take a railroad spike. We're going to see about turning it into a tomahawk. Hang on, let's see what we can do. Alright, so one of the tools we're going to be using today is called a slot punch. Okay, and this is the one that I've made. Let me get close. And the thing is that it's actually shaped oval and it's not flat. It kind of tapers up and up. This is a little off because I've used it a bunch and this isn't perfect. It likes to move around, stuff like that. I'm going to make another one of these down the road and I'll do a video on that so that way I can show you the process. But for right now, we're just going to use this guy. So the plan is, when I've got the railroad spike heating up in the forge right now, but what we're going to do is once we've upset the metal, actually made it shorter, which is what we're going to start off with, when it comes time after basic shaping, we're going to take this and we're going to punch a hole clean through. Then we're going to drift it and make sure that it's big enough for whatever we need. But first, all the shaping is going to be done.
So this part here is called upsetting. It's where the metal is actually, if you will, compressed into itself. You want to keep on doing that until you get to the desired length of whatever you're doing. But for a tomahawk, I really wanted to make it kind of beefy, so I just kept going with it.
Now, from the original, you can already see that we've gone a little bit, not too much, but a little bit. So we're going to keep on doing that. I want to get more material up in here. So instead of heating down here, I'm going to heat back here, and I may quench the front portion so that way it cools down, so that way more metal gets distributed up here versus down at the front.
Just so you're aware, when you're upsetting a piece of metal, as much as I wanted to on this one, it can take quite a while. I didn't actually keep all the video of it because it was just a little bit ridiculous to have all of that. It can take quite a bit of time. Now that I have it suitably upset to where I wanted it, metal compressed down well, I've moved on to where I'm actually hammering out the other end so that way I can make that into a spike. I wanted the spike end to be kind of octagon. It didn't end up the way I wanted it to be, but it came out alright anyway. It's one of those projects where as you move, as you do each part, you kind of figure out how you wanted it to be. I didn't have a firm idea in my head when I started it. I just knew what I basically wanted and kept working towards it. Now we're going to start fullering. We're going to broaden out the head for the axe, so that way we can actually add an edge to it later. Getting something fullered out can take quite a bit of time, but once you're done, you want to start moving on to where you clean it all up. Using your regular hammer, you remove any other indentations from the cross-peen section and make everything look nice. Right now I'm cleaning up the top and the neck on the tomahawk. Because of all that hammering trying to fuller it out and everything else like that, it had caused a couple of creases. So what I'm using is the horn of the anvil to actually help get that bottom part fullered out correctly.
So what do you think? Pop a hole about here for the handle? That's what I'm going to do.
Using a slot punch is just like using any other kind of punch. It just can take a little bit of getting used to. I need to really build a brand new slot punch because that one moves around a little bit, but it still works.
can feel it and hear it when it hits the anvil. And when you roll it over, you'll see a shining spot. You just want to aim for there. There's your slug. And there's the slot. Now, if only I could quit dropping this crap. Next, we're going to heat it up and drift a hole through it. We're going to make it bigger, so that way we can fit a handle. Then, we'll go to the grinding phase and clean it up.
So I've got this real bad habit. I like to really make sure that I wire brush everything, even if it's a phase where I pretty much don't need to. I'm not going to be doing any major hammering on those surfaces, just on the inside where I need to drift it out, but even then I still like to wire brush. It just makes things look nicer, I feel. One of the things you need to pay attention to about drifting is that my drift itself actually will not fit all the way through the hardy hole on my anvil. It'll get stuck. And also, if you notice I'm moving back and forth to the corners of the hardy hole, it helps out. Now once I feel that it's starting to get in there tight, I'll go to this phase where I'll flip the drift over and I'll just hammer it down the rest of the way. And once it starts moving down, I'll quit. Once you've got it drifted, you want to go back through and make sure that everything's square and looking decent, so that way you're not having any issues later on.
Now to clean it up. Okay, so the next two steps are normalizing and then grinding it. Okay. Now normalizing is basically, you might not know this, but metal actually has a grain structure on the inside. And if you fart around with it too much, excessive heating, cooling, quenching and whatnot, you can actually cause the metal to become brittle. Now, because we're working with railroad spikes, that shouldn't be too much of a problem. It's not exactly high carbon. It's about medium. But nonetheless, you don't want it to crack or fracture or break or have any issues. So what you want to do, you want to heat it up to critical temperature where it's really, really red hot, and then let it sit. And it'll cool down naturally, and that's normalizing. It lets the grain structure basically go back to normal. Now, it's a very handy thing. There's also annealing, which is really softening the metal, which is cooling it down real slow. When I do that, I like to throw whatever project it is I'm doing into my green sand, because for the casting, because green sand will actually be able to handle the heat and it'll help it cool down super slow. So it'll anneal very well. Hardening is, of course, where you heat it up to critical temperature and then you quench it in water or oil, depending, and it'll harden that piece of metal as hard as it can possibly get. Then you want to temper it to reduce that a little bit because you don't want it to be brittle. So we're going to normalize it right now. Alright, time to clean it up. Alright, so we've moved on to the heat treating. I'm going to heat this thing up to critical, quench it, and then I'm going to temper it back just a hair. So, hold on. Okay, now clean it off and temper it. So that's what we've ended up with after heat treat and temper. Of course, I did the final shaping of the edge after the heat treat and before the temper. So there we go. Now just got to put a handle on it and give it a test run.